you, Pete. Okay, so thanks very much, Pete. It's a pleasure to open the first Data Eng Conf. As Pete said, we have a fantastic community in New York City, and some of the things I'm going to talk about illustrate the fact that one of the ways that you really win is by bringing data science and data engineering together. I'm going to talk about some of the things I do in the data science group at the New York Times, but just to emphasize, we couldn't do any of that without good data engineering. So as promised, I'm Chris Wiggins. I split my time between Columbia and the New York Times. And I'm going to be talking about data science at the New York Times. Data science, you've probably heard about. Data science has sort of exploded in people's consciousness in the last couple of years. This is just a track of Google searches starting around 2013 or so. Suddenly, there seems to be a lot of interest in data science, and it seems to have captivated a lot of people's hopes and curiosities. And part of that, of course, is related to the fact that jobs in data science themselves are rapidly increasing. You can go to Indeed.com someday and go to the trends section at the bottom and go look at trends for data science, and you can see, or go look for trends for anything you're interested in, and you can see what technologies and what sort of areas are on the rise or sometimes on the decline, which is kind of interesting to see. And because it's new, it means many different things to many different people. So I'm going to start by saying what data science means to us. We take a very old classical view of data science dating from 5 long years ago. This is a graph. Many of you, how many people have seen this graph? Okay, good. So a lot of you have sort of been inculcated into this particular way of thinking about data science. This is a graph from Drew Conway, who's a New York City data scientist and now founder. And this was drawn back when he was merely a graduate student, illustrating one way of thinking about data science as the intersection of machine learning, which is a decades-old academic field combining statistics and computer science, and applying machine learning to some particular domain of expertise. So I'll talk about a few areas where we've seen ways of reframing questions from a domain as machine learning tasks. And the skill set of being able to know machine learning well enough to know which is the right tool for the right job, to listen to a human being, which is difficult, to listen to human beings and try to figure out how to reframe their problems as machine learning tasks, to execute the machine learning, and then to translate what you've learned in a way that's actionable to people is what people generally call data science. Yeah, and just to clarify, when Drew writes hacking skills here, he means not in the post-1983 war games definition of hacking, like breaking into stuff. He means it in the classical definition from the 50s, meaning creative solutions to a technological problem. And that is the kind of thing that you need to do. Good. So this is a definition also from around 2009. If you haven't ever checked this out, Jeff Hammerbacher, who started the data science group at Facebook, after he left Facebook and he had some time on his hands, I guess he was just starting Cloudera around that time. Is anybody from Cloudera here? Good. Okay, so I don't have to say anything. I guess I'm on video. Okay, so Cloudera's awesome. So Jeff, when he was starting up Cloudera, wrote this book, Beautiful Data, which is a collection of essays. And one of the essays is from him about the rise of the data scientist. And he says, at Facebook, we felt like the traditional titles we were using, business analyst, statistician, engineer, research scientist, didn't quite capture what we were wanting for our team. People in this group could be writing in Python or R and trying to do hypothesis testing, regression analysis, implementing an experiment, or implementing an algorithm, writing a product in Hadoop, which in 2009 was sort of innovative, and most of all, communicating the results or analyses to other organizations, members of the organization, in a clear and concise fashion. To capture the skill set required for this, we created the role of data scientist. And that resonates with what we tend to think about as the sort of unicorn-like aspect of being a data scientist, that you want these people to be solving problems that are relevant to the whole company, and therefore you want them to have visibility into and awareness of what are the real problems for the company. So you can't do that if you're going to have a group that's in the basement. You need these people to be communicating with everyone in the company and solving problems that are relevant. Also, R rocks, and being a statistician rocks, but if you really want to contribute to a company, and the company, once you accept that software is eating everything, and you accept that software pretty much has eaten everything, you know that contributing to the company by making an interesting insight, if it's just a deck, is good. But if you really want to be useful to the company, at some point you have to implement and deploy, at least push to dev, right? And better, work with people who can, or yourself, push to prod. You really want to be pushing the product with the work, which is what we try to do in the data science group at the New York Times. So with that by way of background, let me also say something about my own background. My own background, which has shaped a lot of the way I think about data science, comes from trying to get this done in biology. So biology is a field which I think is full of really interesting case studies for pain and data pain. And the problem where you think you understand a complex system, you've been working on it for 100 years, and then suddenly you find yourself awash in data. So it's not necessarily a cutting edge field for all of data engineering, although Uri from Cloudera is going to be talking about ways of putting Spark to work to solve problems in biology. But it is a field where you have a community of people who have been studying some system for a while. It's really complex. They have their own sort of understandings of it. And then they suddenly find themselves awash with an astronomical abundance of data. Although astronomical by biological standards is not the same as astronomical by internet standards, but it was a lot of data. So as one good case study of this, I mean, it happened to me when I was in graduate school, so it had a big impact on me because I was young at the time. So as a good example of how biology had a transformation and had sort of a data moment, when I started graduate school in 1993, the relationship between quantitative modeling of complex things and biology was pretty tenuous. There wasn't a lot of work by computational people in biology that was really impacting the field of biology. And right in the middle of my PhD, this happened on the right. So just so I know if anybody's coming from a science background, does anybody know what this is a picture of on the right? Good. It's the genome, and in particular, it's the genome of Haemophilus influenzae, and in particular, it's the genome of the first living critter to have its whole genome sequenced. So I can remember when I was sitting at lunch with some other graduate students, and one of them came in holding Science magazine in June of 1995, and this was the cover image, and we were all like, okay, this is just gonna change everything. Because once you have the whole genome of some critter, then you can sequence even bigger critters. So once you can sequence this bug, then it was clear that you could sequence yeast, flies, worms, humans. Then you can sequence multiple humans, and then the whole game has changed. Because instead of trying to study some complex system like we did on the left, where you put it in a petri dish and you pour some really bad drugs on it, and maybe it turns blue or maybe it doesn't turn blue, we have just abundant data about this critter. And then we need to figure out, okay, well, how do we represent those data in a way that's useful to people? I contend that the pain that the biology felt is a lot like the pain where you've been studying things by interviewing a focus group of 20 people at a time, and you ask them a couple of questions, and you think you understand, and then suddenly you have tremendous abundance of web logs, and you actually know how they actually use the product and what they actually do. And then you have to figure out, okay, how do we represent them? How do we answer questions that are of interest to the domain experts, which might be people in marketing or product or finance, right? In the same way that we had to turn questions from biologists into machine learning questions in biology in the 90s. So I thought it was a very useful, in retrospect, I think it was a very useful place to learn the sort of pain of data, which we now call data science. And the main thing that I think we learned from that was that the biggest problem is getting a new mindset. Like having a new tool set like Hadoop, right, that's good. But having a new mindset like, oh, maybe we can give data a seat at the table for trying to answer these difficult questions, that actually is much more useful and necessary, right? The new tool set is necessary too, but it's not sufficient, right? You really need people who are like, okay, let us take data seriously and think hard about how we're going to use data to drive difficult decisions. Which brings us to the New York Times. So the New York Times is not a recent company, and it's not by birth a technology company, right? This is an old company. This is the first image of the New York Times from 1851 when it was the New York Daily Times, and it was merely a newspaper. That is, the only way of getting information to people was in the form of a dead tree. And when you gave them that dead tree, they gave you back nothing. You learned nothing about the way they interacted with the product. And that was the soul of the interaction between the New York Times and its users for the first 88% of its existence, right? Dead tree. How on earth are you going to put data science into a company like this? Well, to make it more clear, let me say a little bit about the org chart of the New York Times. Here is the org chart of the New York Times. And in fact, here's the org chart of most traditional media companies. Church is the people who keep the craft of journalism, right? They keep and defend the craft of journalism, and they think about that craft. State is everything else, right? Sometimes called the business side. and I sit solidly in state. So I want to make clear how that relates to things that you may know. Sometimes when I tell people, oh, I'm a data scientist at the New York Times, they say, awesome, I love the upshot. You guys do really good work in data science. And I said, no, those people are awesome. They're great. I love the upshot, props, but I'm not in that group. Those people are a church. They're sweet. They're great. They distribute their code on GitHub. It's very tech leading, but I just want to make sure that you know that's not what I'm talking about. Or sometimes when I say I do data science at the New York Times, people say, oh, I love the interactive graphics that your team produces. And I say, yes, those people are awesome. I'm not with those people. Those people are church. They're great, but I'm not solving those problems. And in particular, the particular part of state that I sit in is engineering. So you may not think of engineering as an essential part of media companies. And again, for a place like the New York Times, that's pretty fair for the first 88% of its age. But I do sit in engineering, and in particular, I sit in a group called Data Science and Engineering. So there's a group in the larger engineering enterprise called Data Science and Engineering, which brings these skills together. The data engineers who are trying to capture, curate, make useful and actionable all of the data that the company generates. And although it's only a little over 3,000 people, we have many different functions going on in a company, right? After 164 years, you build a lot of diverse muscles, and all those muscles generate interesting data sets. And the data science team that is trying to learn from those data. Those may sound like different functions, and I feel like society has sort of talked about data science and data engineering are different things, but I want to show you that they are intimately related. Josh Willis put it in words about a month ago in a way that I really resonated with. Josh, who recently left Cloudera, he said, what do data scientists talk about when they get together for lunch? How hard it is to hire data engineers. It's true. None of the stuff that I could talk about, I could do if there weren't good data engineers at the New York Times who had made the data useful, right? Who had thought really hard about how are we going to capture the data, how are we going to make these data useful, right? And the people on my team have to work well with the data engineers. So in our group, like we're in the same place in the org chart, we sit next to each other. When something's pathological, we walk over to the other cubicle and ask, why is this data pathology there? And nobody knows the pathologies in your data better than the data engineers. So it's very useful to work closely with them. Now, I haven't really answered why you have an engineering team. The reason that a media company has an engineering team is an unintended consequence of the World Wide Web. So here, just like on the left, which is the first ever edition of the Dead Tree New York Times, on the right is the birth of the New York Times as a website. So on my birthday in 1996, the New York Times introduced a website, and they reported on it with the quaint headline, "The New York Times introduces a website," which sort of was the style of the time. And what that has led to is an abundance of data, right? So today, millions of people go to the website every day, and millions more interact with the digital content via mobile devices of one form or another, right? So unlike for the first 88% of the company's existence, where the method of conveyance was dead tree, now the method of conveyance is digital. Now the exciting thing about digital, when people put up websites, they were like, ooh, this is cool, this is going to be like some new way of communicating with people. That's not what's cool. What's cool about digital is the fact that, like with a radio sits there and it receives photons and it amplifies those photons and plays it in your ear, but the radio station doesn't find out what you listen to, right? They have no knowledge about what you're listening to. Broadcast TV, same thing. Digital, on the other hand, is a communication, right? Every time you point, click, scroll, en masse over, right, you are making a request, right? And that request is received by a website, which, if that website so chooses, can log it, right? And can learn at scale what people actually feel about your product. This is not violating any corporate secrets. You can open up Google, or you can open up Chrome, and you can go to the developer tools, you can go to the network tools, visit any website, and you can see what information are you sharing with any website, right? So, some random website I went to a couple of years ago about the sports, and here's what my browser was telling the New York Times, right? A bunch of cookie information, where I came from, how many characters I had read, right? And unless you think that the New York Times is the most technologically advanced company in the world, I'm sure you're giving up at least this much information when you go to Google or Facebook. And don't even think about how much information you're giving up on your mobile phone, right? I mean, like the reason Google now can tell you like how many people are at this coffee shop at every hour of the day is because they're tracking like where you are all of the time, all day. So enjoy that. And all of these interactions with the world are generating an abundance of data. This is a great quote about data exhaust. The quote is, social activities generate large quantities of potentially valuable data. Data were not generated for the purpose of learning. However, the potential for learning is great. Any guesses what year this was written? You haven't had enough coffee yet. It was written in 1993 by John Chambers. Anybody heard of John Chambers? Okay, so John Chambers invented S, which became R. Right, so I put this in part to say that there actually is like a literature out there that we can draw on of people, in this case from Bell Labs, thinking for years about what are you going to do with abundance of data exhaust? How do you go about and learn from observational data at scale, including digital data? So a couple people knew it, right? Like Bell Labs, they saw it, right? They saw it coming in the 90s. But it took a couple of decades more before normal companies that had not yet been eaten by software, to see that the web is not just like your online presence, which I think is the way people in media thought about the web in the 90s. They're like, okay, this is going to be our online presence. Instead of going to brick and mortar or buying the dead tree, you know, we have some presence on the World Wide Webs. But people now realize that the web is like a microscope for understanding your entire audience at scale. Right? If you have the technology in place to log, and if you have the mindset in place to learn, right, you can really understand your audience at scale, and you can use that to drive marketing decisions, product decisions, business decisions. Moreover, people I think now realize that the web is also an experimental tool, right? Because if your product is code, then it's a matter of just encoding, showing different things to different people, and learning how that affects people. And once you're doing experiments and you're allowing experiments to drive your decisions, you're really doing an optimization. Right, so that's been a big change in mindset, to think about the web not as like a place where you push pixels around, but a place where you learn what your audience actually does, what your audience wants. You can do that if you really have the right mindset about the value in your data. Right? That's why sort of like Harvard Business Review has these blog posts about data being the new oil. Right? There actually is a lot of value there, but you need to think clearly about the whole value chain. So that's all cool and fun and intellectually interesting, but the New York Times is not like an academic place. It's not like we made a data science group because we want to just think big thoughts. The value of a data science group is to try to explore how the world is changing. And the graph on the right is a good graph about how the world is changing, and I think it makes clear that it's not just an academic exercise to think about how to understand the audience better. Let's zoom in on graph on that. So another unintended consequence of the World Wide Web is an amazing change in advertising. And that's relevant to the New York Times because for the last 150 or so years, the craft of journalism has been intimately connected with the business of newspapering. And in the business model of newspapering, the income is advertising, right? So in the late 90s, it was good times, right? You basically could just give away the New York Times for free because the advertising was paying the bills. And then something amazing happened, 2004 through 2008 or so. And this is not the end of the economy and like Lehman Brothers, et cetera, et cetera. This is before that. There was a big change where advertisers rethunk a classic line in advertising. So there's this classic line in advertising. The problem with advertising is I waste half my money, but I don't know which half. Right? So once you have the digital and you actually can track the way people interact, then you know which half. And so advertisers started rethinking where they were going to put their advertising spend. To zoom in on that, every publisher is now challenged with trying to think about what is going to be the business model of journalism for the next century. And at this point in our species, you know, we don't really know. Like, we are still in search of a sustainable and scalable business model. So it's not just an academic exercise to learn from the data. By the way, just to zoom in on where the money went, you can keep track of advertising revenue in Google, Facebook, magazines, newspapers, and you can see this amazing trend where advertisers just sort of move away from newspapers and move towards the Google. So the New York Times takes this seriously, right? This is an existential challenge to the business of newspapering, which again is intimately connected with the craft of journalism. And the New York Times has taken a very hard look at that. If you want to read a great document about innovation in general, but also around media and publishing, there's this excellent document, which is usually just called the Innovation Report, about 96 pages. It was leaked to BuzzFeed, which is how we, as a species, all now have a copy of it on the interwebs. But it's a great document about the ways that a legacy organization in particular faces the challenge of innovation, and what are the challenges in process that keep an organization from becoming a tech company. One of the recommendations in the innovation report is that there should be more engineering in everything, that there's a role for software and for software engineering in church and in state. And that's one of the things we're trying to do broadly. So broadly put, the goal of the data science group is to solve problems in newsroom and business throughout the company, try to liberate and learn from the data we have, try to solve using machine learning and predictive and prescriptive tools, business and newsroom problems that are facing the company, right? And that means interacting well with people throughout the company. So what have we learned? I tend to think about, because I come from a machine learning background, like my published research at Columbia is all about using machine learning to answer questions in biology with biologists. I tend to think about the work in the group as broken up in different types of machine learning. And usually I think about that in terms of, are you doing unsupervised learning, supervised learning, or reinforcement learning? Or roughly, in words that I can use with non-technologists, are you looking for descriptive analyses, prescriptive analysis, or predictive analysis? And I'll show you examples of things that we do. And framing it that way, I think, helps people think about, how is this work that you're doing going to integrate into my process? And if you'd like to know more, there's a class that I taught on this with, I co-taught it with Jake Hoffman in the spring, called Modeling Social Data. So an example of a predictive analysis. So one thing you might want to do that's predictive is you might want to look at all your users and say, can I predict which users are going to go from a non-reader or a repeat reader to a subscriber? Right, so that's something that you want to predict, and you might like to learn a model that takes in as input a data set in which every row is an individual. All the columns are everything you can think about that person, right? And that's an act of creative computational social science. It's an act where you work closely with people from different parts of the company. And then there's one sacred column, the column that's like, did they cancel their subscription? And that's really the goal, is to predict that column from all the other columns. Right? That's a classic machine learning task, but it's reframed in a way that speaks to people who fear people canceling their subscription. Right? So you can sort of explain to the rest of the company, here's the thing that we want our users to do or not to do. Let's reframe that as a prediction problem and learn what we can learn about their behaviors. Of course, you don't just want to predict who's going to become a subscriber. You also want to predict which of your loyalists are suddenly going to cancel. And to do that in a way that's useful to the company, you want not only to solve the engineering challenge of finding the at-risk people, but the science challenge of figuring out what are the risky behaviors. That is, you want a model that's not only predictive, but also interpretable. So that's a big challenge, to take all of the different attributes, which here I've just called super cool stuff, because I can't tell you unless you come work with us, and then to learn some sort of significance, and to say, well, these are behaviors that are good, and these are behaviors that are bad. And in many ways, that's a lot like the kind of things that biologists have been trying to do for the last 10 years. So, a paper I wrote in 2007 was about exactly this. You take a bunch of genes and you get to watch them going up and down, and then you want to predict which genes go up and down. But if you're the yeast biologist, you don't really care which genes go up and down. You want to know, what are the control knobs that make those genes go up and down? In this case, it's sequence elements. So a lot of the way I've reframed problems at the New York Times is, at a high level, pretty much the same thing I was trying to do in biology, trying to take things that were of interest to the biologist, reframe it in terms of questions that they can understand why that's an important question, and then order those hundreds or thousands or infinite number of possible features by how important they are. Other prediction problems at the New York Times. Well, unlike many modern media companies, the New York Times still makes dead trees, right? So we still have a very important print business, and there are interesting logistics and optimization problems around there. Just delivering the right number of copies to the right store, you can actually save many, many data scientist salaries if you do that right. Again, I can't tell you anything business sensitive about how many monies we're talking about here, or what particular models are trying out here, but one of the things we've done in the last year is to build out a framework, like the infrastructure for doing careful statistical experiments on multiple algorithms on multiple stores, right? So it's a very real world example of the kind of thing you might do in a petri dish. So that's a prediction problem. One thing that sort of blends prediction and description is building better recommendation engines. So it's a problem well known at Spotify. Here we are. So at the New York Times, you're probably familiar with the recommendation engine module or widget. That's on the lower right-hand side of the homepage. But there's many, many things that we can do better if we better understand who likes to interact with what type of content. There's a great blog post about this that Alex Spanger, who's going to give a talk tomorrow afternoon, wrote about using collaborative topic models, which is a type of generative model for trying to model all of the content and all the interactions with the content at once in order to build a better recommendation engine. Just pushing that further in terms of the ways that some of our tools blend prediction and description, Dale Kim, who's in my group, also has built out this awesome internal tool called Readerscope, which takes the idea of topic modeling even further and allows you to interact with and try to interpret the different types of content that are read by people in different places of the world or thin sliced by different demographic information. So you can say to an editor, here, like, what do people read in France? Well, here's the kind of things people read in France. And it's all done in Python, in Flask, in D3, and it gives you an interpretable and interactive tool, which is, in my experience, you can write a paper about machine learning and the punchline is a loss function and a test loss or something like that. But if you really want to work with real people, if you want to make something that's interpretable to CEOs or four-star generals or whatever, just let's say people who don't know calculus, it makes a big difference if you can just stand up a simple prototype. If you can give something that people interact with, take the machine learning model and make it something that people can play with, just goes miles towards helping people feel like they understand in their guts what you're actually doing. There's some fancy math behind that, but since I don't want to spend a lot of time on fancy math, trust me, there's some generative modeling behind it, which is state of the art, and allows us essentially to model our audience. Ultimately, this turns into optimization problems, but it allows you to get some insight, but also drive targeting methods if you understand people at scale. I haven't said anything yet about prescriptive, right? So describing people is like, okay, I have millions of users and 20% of them are baby boomers, and 10% of them are this other set. That sort of gives you a description of what is or what happened. Prediction is saying, can I make an accurate model that predicts, say, who's going to cancel their subscription? Prescriptive is when you say to somebody, among the set of actions you are choosing, here is the action I recommend for you. So an example of a prescriptive model is this project called Blossom. So last fall, the New York Times created a new unit in the newsroom called audience development. As they put it, there's journalism, and then there's the art and science of making sure that that journalism gets to as many people as possible. Or as the senior editor said, we want our stuff to be read. So they created a new group that was about how do we go about making sure that that content is read by people and discoverable and discovered. So the audience development team has to think about things like, how are we going to promote our stuff on all of the social channels, right? Facebook, Twitter, Snapchat du jour next year. And the stuff we have, well, that's hundreds of URLs every day. And there's all these different sub-accounts. So if you're an editor in the audience development, in principle, you're keeping in your head, on the order of 1,000 URLs, on the order of 40 different social channels, and you're making decisions about the way to present it and which is the right channel every 15-minute period all day, right? So that's a lot for any human being to keep in her or his head. So one of the projects we worked on was reframing that task as a prediction problem. Like, can I predict social engagement with this story if it is promoted or if it is not promoted? And if you can do that, then you can make prescriptive statements like, I recommend that you promote the following story on the following channel right now. So so on the back end, what does that mean? Well, that means a bunch of MapReduce, that means a bunch of Python, that means a bunch of scikit-learn, that means a bunch of cross-validation and make sure that you're making something that's statistically significant and accurate. But I can't get editors to open up Python and interact with it on the command line, right? Instead, editors spend all their day in Slack. So we built this very friendly Slack bot called Blossom, and you can interact with Blossom all the time. You can ask Blossom questions like, hey, Blossom, Facebook? Blossom, what should I post to Facebook? And Blossom will make recommendations about what things might be posted in Facebook. Blossom also has an alert function where in the middle of people having a pleasant chat among humans, Blossom bot can come in and say, hey, seriously, you really should promote this story. So Blossom bot will come in and interrupt your process. So that's an example of prescription. So prediction is like I try to assign a score to a person that tells you likelihood of happening. Prescriptive means we've decided in advance what is the action set, and I'm going to recommend to you what is the argmax over the action set of some reward. What is the choice that we recommend to you now? So if you think about data science and process, you sort of think about it like this, like, oh, I have a bunch of data about people. I'm trying to decide on a new product or a marketing campaign, so maybe I want to segment people. And that sort of exploration suggests to me the new campaign or the new product. And then maybe I observe people and how they interact with this product once it exists, and that allows me to learn how to predict the thing I really care about, which might be a business KPI, from the things that I can observe easily, which might be engagement features that you can measure right away. And then that suggests you, like, of the hundreds of things that might be correlated, the subset that seem really correlated, some of them might be causative, and so you do some tests. Once you've done some tests, then you can do some optimization, and then you have KPIs, and you just mail it in an Excel spreadsheet to the CEO every morning. That's the way we think about, like, a company. And of course, none of that is like that, right? It's all iterative, right? Just like science, right? So you do some experiments, you learn some, like, key leading indicators, then you see how those leading indicators fail to do what you think they do in new products, right? You go back and you iterate, right? And you optimize. It's much more like that. So how do we get this done? Like creating a data science team within a 164-year-old company with thousands of people takes a lot of things coming together. It's not just about the choice of which database to use, right? And in fact, in some ways, the things are at the bottom. So when last year, I read a lot of books about how to integrate technology and drive organizational change. One of the most useful was a book about the US military, and I got this statement from the United States Air Force that if you really want to get things done in an organization, you need people, ideas, and things in that order. So the things are the things we usually talk about, the Hadoop, the method, right? The statistical KPI, say, right? And the ideas are things like the change in mindset and the idea of data science. But you can't get anything done unless you've got people who get it and who are willing to bless data science as a thing. So let's talk about the things, like what are the things that we deliver? We try to balance between building data prototypes, which means that we need software engineering. Like we need a skill set that includes software engineering and the ability to at least ship to dev, right? To build some prototype that people can interact with. We also want to impact the engineering process, which means we need to be able to ship to prod. Like we want to build APIs that other engineers can call on. And more broadly, if we really want to impact people who aren't interacting with engineering yet, parts of the organization for which software has not eaten their world, we're just trying to impact their roadmaps. We're trying to give them advice that changes their decisions about what's the most important thing for the next quarter. Prototypes, well, I already showed you an example of a prototype. This is a screenshot from Dale's work before he came to the Times, just trying to ingest a bunch of content and then render in a way that's interpretable the topics around different parts of a website or different corpora of texts. And I already showed you a prototype that sort of manifests that that's an internal data product. We build APIs, so we deploy in Puppet, and we work closely with software engineering teams like the personalization team. And as I said, impacting roadmaps is a business term for getting people to change their mind. Like running a company, being an operator in a company means making and defending difficult decisions. And everyone in the company, whether you're technical or not, is making difficult decisions, and we try to find places where data can be useful for driving those decisions. Like I said before, ideas are more important than things. So what are some of the ideas that we've been trying to promulgate? One is that data science, as they say, is not done in a vacuum, right? So by sitting among the data engineers, it's been very useful for getting things done, for understanding the discrepancy between your model of how you think the data were generated and how the data actually were generated, right? Many of the things that we call data munging or data cleanup are really about the disconnect between your model of how the data were generated and how they really were generated. So it helps to sit one cubicle away from the people who generated the data. We sit alongside a data visualization team that does a great job building awesome D3-powered internal data products. We think a lot about data product. Like in the Blossom example, I can't make the editors fire up Python, so I have to make a product that I can integrate into their process. I wanted to name it something that wasn't like, predictive classifier for blah, blah, blah. I named it Blossom, right? Like then they know, okay, that's an algorithm. It's represented by a little set of flowers. I know what it does. It's not going to bring down the website. It's going to be useful to me. Those are product decisions. Multi-literacies, meaning I can't ask everybody in the company to be functionally literate in data science, but I can try to help more and more people be critically literate and rhetorically literate. Rhetorically literate meaning they know how to tell a story in which data science is part of the story, and they know, they know how to interpret a graph in a way that helps them communicate to their team or to their stakeholders or whatever. And critically literate meaning they know when I'm lying. So if I tell them oh, I'm going to do some amazing thing with data science, I want them to be critically literate enough that they can say, no, you are not going to do that. That's not Just not possible. It saves us all a lot of time as a company if people understand data science well enough to know the limits of data science. And very useful to getting this done has been data embeds. So we try to take members of our team and embed them in different groups. So one person is embedded in the personalization team, another in the new markets team, another is basically embedded in marketing, and one embedded in the newsroom. And you don't, like I said before, you don't want your data scientists locked up in a basement doing Lord knows what. You want them forward deploy, like in the trenches with the people who are going to be putting their stuff to use. It's going to make your models better, make your models more interpretable, make your product decisions wiser, get better iteration with the customers effectively for internal data products. Most of all, though, we couldn't get this done unless we sat very close to the data engineers. And so I try to hire and build a group that balances between sort of IPython as a skill set and Puppet and deploy as a skill set and proper data engineering as a skill set. In many ways, we are the most demanding customers for the data engineers and give them the hardest time, and hopefully sometimes are useful to them. In short, a new mindset is more important than a new tool set. I think we've done that at the New York Times. I was excited about a month ago when I saw the CEO interviewed somewhere, and he said, what's happened in the last 12 months is a growing understanding from data science and machine learning about how to relate the way people use the product to subscription and retention, basically. So even to have the CEO of your company talking publicly about data science and machine learning, I think indicates that you're a good place for driving org change and for contributing to the values of the org with data science. People, ideas, and things in order. And the other important thing about people is that I should say who actually did the work. So I used the academic first person in this talk, which is every time I said I really meant we. And every time I said we, I really meant they. These are the people who actually did all the work. And those people are coming from a variety of places. So Alex, who's going to talk tomorrow, is coming from a background in CS and neuroscience. Colin's coming from a background in CS and startups. Dale is all but done with his dissertation at Brown. Anne was an astrophysicist and did 2 postdocs in astrophysics. Dorian's coming from a pure math background. And Nick did hard time for 7 years in ad tech. And hopefully you've met these people. I encourage them all to go to meetups in town and learn and to teach about what we do. And I encourage you to check out Alex's talk tomorrow, which is more about using generative models for building a better recommendation engine. And with that, I still have a few minutes left for taking questions. Thank you very much.
If you were talking about the Blossom tool, and if Blossom can predict, say, virality of a piece of content, why not just push it into Facebook or into Twitter?
So part of that is the difference between data-informed and data-driven, right? It is not the case that all of the nuances of the way that you publish are captured in any single scalar, so any single number, right? So it's far better to make suggestions to editors than to just put it in the loop and have it be fully data-driven, where an algorithm just pushes directly. There are all sorts of ways in which editors are smarter than Python. And in fact, in many ways, that is the value add of the New York Times, right? So there's all sorts of processes that involve actually communicating with people, such that if we were to replace them with algorithms, there would be no moat between the New York Times and any other place, right? Because anybody can build an algorithm that's going to, say, generate text, right? So yeah, I still think it's better for trying to, I think it's still better to think about this as, in the way that you wouldn't want your doctor to be replaced by, robo-surgeon yet. I think still there's a lot to be learned in which we can say to the editors, of all the hundreds of stories and all the hundreds of social channels and all the hundreds of times of day where you might promote this thing, here is something that seems to be a real good idea. And sometimes they follow it, sometimes they don't. And in many ways, they're learning from it. Also, this project has only been live for a couple of months, so you would want to test something out for a while before you're just like, okay, robo-editor. There's one question back there, and I think you had a question as well. And I'm not sure if you're moderating or I'm moderating. If I'm moderating, then I would like to hear your question, please.
Well, earlier on you spoke about the concept of people, ideas, and things, and you mentioned that it came from a military book.
Yeah.
And I'd be very interested to find out about the title, where it came from.
Sure. So there was an Air Force colonel called John Boyd. There's a book about him from 2002 called Boyd, the Fighter Pilot Who Changed the Art of War.
Is he the Korean guy over Vietnam?
He was in Korea.
Korea, okay.
He was active in Korea.
Okay.
And there's sort of a subset of military thinking which became known as the Reformers in the 80s, which promoted a philosophy which we would probably now call agile.
Scrum.
But yeah, many things that look like Scrum. Basically, like, stop building ridiculously large planes, start building smaller or tanks or whatever, start building smaller tools that are the right tools for the right jobs. And in the latter third of the book, when he actually ends up in the Pentagon, that's where it sort of goes from thinking about things to thinking about people. Like, what are the processes in the Pentagon, which is a large bureaucratic organization that thwart innovation and thwart getting things done.
So what was the title again?
Boyd, B-O-Y-D, Boyd. He's become very popular among startup people. So I actually heard about it from various thought leaders tweeting about Boydism. There's another question in the back also. Thank you.
A question about change management. You mentioned that you have needed to read military books to change things at New York Times. Can you talk about your hardest challenge?
It's hard to choose. There's so many hard challenges. And I should say that I think the interesting ones are the ones that are generic from field to field. And I think coming from biology was very useful there, because there were really hard conversations in biology in the late 90s about, like, what are the criteria for getting a grant accepted, for getting promoted? People were like, should we do away with hypotheses and just like have grants where you just collect data and then figure out what happened? Just do away with the scientific method. I mean, and it was intimately connected with money, so people, it wasn't like an academic question. People were really interested in these things. I think the challenges are maintaining communication all the way from the engineer to the deciders. So you need to make sure that you're doing something. Something I say to my group all the time is, don't work on something that you couldn't explain to the CEO why you're doing it. I don't want to have us being like doing sort of research projects just for research. I've always wanted to find projects where it would be clear to anybody in the company why that's a valuable problem. Jared Lander may be here. So I gave a talk about a year ago, and somebody asked me, like, you're a fresh data scientist in a new company, how do you decide what to do? And I said, well, what I did was I showed up, I studied the org chart, figured out who were the deciders, I figured out what they feared, and then I built a model that predicted that. So I think part of the challenges are just making sure that you're doing things that are relevant to things that people actually care about. And the solution to that is just being a good listener, right? That's why people say that a big skill of being a data scientist is being a good communicator. One of the half of communicating is like really listening to what people actually want. Make sure you build something people want, as they say, right?
Great, thank you.
Okay.
We're out of time, so
Okay.
If you want to chat with Chris further, he's going to be in the back, actually on the right here, stage right, in the Hunter room, if you want to chat with Chris. Next up here, we have Rafe Colburn from Etsy on this floor. And if you're interested more in hearing about how data science is changing publishing, that's upstairs. Kai Harlan is here, who was the former chief scientist at BuzzFeed. And a colleague or a student, I believe, of Chris's at Columbia.
Got him that gig.
So Kai Harlan is going to be on the 7th floor talking about data science and publishing. So you have about 5 minutes to sort of run around, and thanks.
Thanks.
Thanks, Chris.
Sure.